crimping hall to the packing hall. So this is the thing which had happened, and the take-home message from this sad incident was that, really speaking, every hazardous operation should be assessed for the risks. Inventory of explosives in any operation should be kept at the bare minimum. Design of the buildings have an important bearing on reducing the effect in the event of an explosion. This is what the layout of the building was before. This was where the incident happened. This is the table where the operator was sitting, and these were the racks on which these detonators were kept. This explosion took place, and the whole explosion wave traveled this way. And this operator, who was thrown away about 20 meters, he was actually entering the building by switching off some light. And as he was entering, the explosion took place, and he was thrown off about 20 meters. There was the other operators who were inside the crimping cubicles. Nothing happened to them. Detonators were there inside these cubicles. None of the detonators were affected. So subsequent to the incident, we changed the design of the building, and now what we have really split it into this, and then we have reduced the limit of the explosives in each individual cubicle as well as over here also. And then we have got weak walls over here and a blast wall kept over there. This is the inside of the crimping hall. That is the far side. That is the far side where the explosion took place from that side, and it traveled this way. As you see, it was damaged, but the people who were doing the crimping, were not affected. Inside this is the room where the explosion initiated. This is the area where the operator was sitting. And just a view from outside after the building. So that is the incident, a very sad incident, a very costly way of learning from an incident, because we keep on saying that incidents help us to learn. But such learning incidents, God forbid, no one else should be able to experience. Thank you.
Thank you, Mr. Goa. I think that is a message I wanted to give, and I'm very happy that you have shared your actual experience with even the photographs and all that with us, and there is a take-home message for all of us. And as you said, it's a very costly, certainly not the desirable way of learning, but once happens, you can't reverse it. But then we take advantage of that, what has happened, and learn from it. Thank you very much. And thank you for completing it before your time. So much of importance has been given to the time now. The next talk is by our Joint Chief, Mr. N.T. Sahu, explosion in raw materials storage shed. Mr. Sahu is Joint Chief Controller Explosives, will provide the detailed case study on the explosions in raw materials storage godowns. Mr. Sahu is a postgraduate in physical chemistry from Marathwada University. He has more than 29 years experience of administrative experience in the field of manufacture of explosives, pressure vessels, gas cylinders, petroleum terminals, etc. He has worked in various parts of the country in various capacities. He is a nominated member of certain conventional weapons, CCW, in the Ministry of Defense. At present, Shri N.T. Sahu is posted at Nagpur as Joint Chief Controller of Explosives. Over to you, Mr. Sahu.
Thank you. Thank you, Explosafe. Thank you, Mr. Amar Gupta. And thank you, everybody, giving me the chance over here to give the presentation on the explosion in the raw material storage shed. In fact, when I am the person from the statutory authority, I feel so. It is my duty to give the objective of the act, what we are dealing with this. Explosafe Act 1884 objective, main objective to prevent accident amongst others, to ensure safety, provision. It is an act to regulate the manufacture, possession, use, sale, transport and importation of explosive. Power to make rules for licensing under Section 5 of the Explosafe Act 1884. Powers to make rules conferring of inspection, search, seizure, detention and removal of explosive under Section 7 of the Act. Empower for extension of definition of explosive to other explosive substances under Section 17 of the Act. Notice of accident under Section 8 of the Act. Magistrate inquiry under Section 9 of the Act. Central government empowered to central government inquiry under Section 9A of the Act. Then punishment under Section 9B of the Act. Accident. What is an accident? Accident is an unexpected event or occurrence. Though we are giving the more attention over there in any manufacturing unit or any while going or while in our house or anywhere, even then also accident occurs over there. So it is the that is unexpected event or occurrence. Objective should be zero accident. However, residual risks of accident may remain. In accidents, there is loss of life and property. Explosive manufacturing have a high potential of accidents if preventive safety measures are not taken. Causes of accident using the impure raw material. In earlier session, number of speakers they have spoken about this. But even then, I have made over here the raw materials, lack of knowledge about the raw materials, the process, unit operations like mixing, drying, standing operating procedures, etc., intermediate material, productions, effluent, property of material handle, the equipment handle, improper maintenance of the equipment, lack of training, understanding of human behavior, human error. Most of the accidents are occurring due to negligence or human error. And this accident study, case study, will give the impact on how this accident occurred due to human error, negligence, and keeping the material which are not compatible to each other. Accident in raw material storage building, a case study. The raw material storage building was being used for storage of ammonium nitrate, sodium nitrite, emulsifier, micro balloons, common salt, thiourea, flammable materials like juice string, powder, CV boxes, etc. and others. Everything was there, oxidizers are there, fuels are there, only there is a requirement of the initiation. The building had 3 doors, ways provided with tube light above the doors, duly connected through cables to the electric switchboard fixed outside the building. Adjacent to storage building, one aluminum weighing room, there was a gap between GI sheet, roof and walls. The raw material was stored at least 2 feet away from the wall of the storage building. A consignment of about 9 metric ton aluminum powder was received by the company 2 days prior to accident and was kept in the aluminum weighing room existed adjacent to the raw material storage building as per the statement. And that is the thing what the Mr. Amar Gupta and Mr. Sahu also told, that nobody are disclosing the fact, and that's why accidents are occurring again and again. If you disclose the fact, right, that investigation will be there and the right cause of accident will be found out over there. One day prior to accident, factory was closed on account of weekly off and no activities. Heavy rain with storm at about 18:30 hours for about 45 minutes on previous day of the accident. There was no electric supply in the factory whole night. And it was a month of May that I am telling what may be the temperature. On the date of accident at about 4:30 hours, security guard switched on the generator installed at about 170 meters from the site of occurrence and returned back to the factory gate, which was near to the spot of occurrence at 5 hours. On the date of accident, in between 5:15 to 5:25 hours, the security guard and workers noticed smoke and fire coming out between the gap of walls and roof of the building. There was no direct explosion. It was the explosion followed by the fire. At about 5:30 hours, the raw material storage building was under fire, witnessed by the staff and security guard. After some time, staff, while going away from the storage building, they heard a deafening sound of explosion. On investigation, a crater of size 16-meter dia and 9-meter depth was formed due to explosion. The building size was 24 meter by 12 meter. The building was completely razed to the ground. Other buildings at about 1.5 meter and 9 meter were also razed to the ground. Another aluminum storage room and G+1 staff quarter building at a distance of 46 meter were heavily damaged. The aluminum powder was spilled alongside the edge of the crater. This was the most point of the investigation of this accident, aluminum powder. Samples collected from the site of the accident for the presence of perchlorate, sulfur and aluminum. On discussion, cause of the accident, on chemical analysis of the samples, none was found contained perchlorate and sulfur. However, the grayish substance smeared with soil collected by removing debris near the crater in presence of representative of the company found contained aluminum. The building was stored mixed with oxidizers, fuels and gassing agents and other flammable materials. Wide gap between the roof and walls and bottom of the shutters and floor of the godown. There was heavy rain with storm and lightning before 9-10 hours of the accident. Spillage of aluminum powder along the edge of crater indicates the storage of aluminum in storage building. Fire before the explosion. Presence of aluminum detected in the samples. As per interrogation with the eyewitnesses, there was no sabotage. There was no electricity whole night. Short circuit rule out. Ammonium nitrate was kept duly packed in bags. Reason to believe that an accident occurred by contamination of AN is ruled out. Now, properties, that is hazardous nature of AN. References of the studies of the hazardous nature of the ammonium nitrate suggest that contaminants like organic materials, carbonaceous materials, grits and certain inorganic materials including chlorides of sodium, some metals, metal ions and compound containing metals may increase the explosion hazard. Violent reaction may occur with molten aluminum. Ammonium nitrate by itself does not burn, but in contact with other combustible material, it increases the fire risk. It can support and intensify a fire even in the absence of air. When stored in the vicinity, it readily participates in the explosion. Most probable cause of the accident found, there was a heavy rain a few hours before the accident and its easy entry into raw material storage shed in which aluminum powder was stored, point to the probable cause of accident due to explosive reaction of aluminum with water. There was the raw material such as gassing agent, wax, that is fuels, and oxidizers like ammonium nitrate enhance the fire and explosion. I have found out the 3 empirical formulas for calculation of ammonium nitrate involved in the accident from the different agency. One I have taken from the internet, and one it is from the Defense Ministry, and one is from the IIT Kanpur, the study material. The empirical formula by Government of India, Minister of Defense, in accordance with the communication sent from the Government of India, Ministry of Defense, New Delhi, dated 21st February 1973, addressed to the then Chief Controller Explosive Nagpur, Sri I.N. Murthy, the radius of crater is related to the weight of the explosive as per the formula. This is the formula, that is radius of crater formed in the meter, R is equal to K into P by 1 cube, net weight of explosive in kgp. K, it is a constant which varies from 0.4 to 0.8 depending upon the nature of soil. K is equal to 0.4 for hard rock. That it is coming to 2.4 tons. I was not happy with this formula. Then I have found some another formula. Then empirical formula by Department of Chemical Engineering, IIT Kanpur, in accordance with the course material on quantitative risk assessment and hazard analysis in chemical industry of the Department of Chemical Engineering, IIT Kanpur. In January 1993, when an explosion occurs on the ground surface forming a crater, 1 ton of explosive approximately correspond to 60 cubic meter of the crater volume. So formula is that its diameter is equal to 3 V under root V by height, that is the depth of the crater. That is V is equal to volume of crater as depth, and from this formula we could calculate approximately 38 tons of the explosive ammonium nitrate involved in this case. Then third empirical formula which I found from the internet, it is by Daniel Abrosini, Bibiana, Luciani, Rodolfo Donesi. In according to this formula, this quantity is coming to 55 ton. While investigating the case, according to statement, they told that it is about 35 to 40 ton of ammonium nitrate was involved, 35 to 40 ton of stock of ammonium nitrate was kept over there. And according to second formula from the IIT Kanpur, we could find out, we could come to the conclusion 38, and that may be the 38 ton of ammonium nitrate explosive was involved in the explosion. Be cautious, life is precious. So whenever you are in the any explosive industry more prone to the accident. But if you are observing the proper safety, proper knowledge, and mostly the important is that we should know the property of the material what we are handling. If the person is not knowing about me and I am doing the friendship with me, what is the use of that? I may be any type of man. Okay? So it is definitely I will say that one should know the property of the that material what is handled over there in the manufacturing unit. This is the rough sketch what I had drawn, that what this is the number 1 is this where that storage shed was there. Then number 2 this was the weighing room, and this was another aluminum storage, and this is 4, it is the cabin, security cabin was there. This is the gate, there was a road, and this is number 5, the G+1 story building was there. These are the quarters over here, and this was the number 7, this is G+1 stories quarters building, this is one. This is 8, that air melt tankers were parked over there. This is BMD vehicles, and this is the explosive van, number 10 and 11 were parked over there. Accident occurred over here. And in this accident, there is a loss of one person in the accident and injury to the 2 persons. After this accident, that government also compelled all the explosive industries to bring the ammonium nitrate rule 2012. And earlier, even industry people, explosive industry people, they were saying that ammonium nitrate is not an explosive. And after this accident, it compelled to all the industry and to understand what is the hazard involved in the ammonium nitrate. Thank you very much.
Thank you, Mr. Sahu. It was a very educative analysis for the accident, and I totally agree with you what was the cause of accident, and I hope that we don't do such a thing that put fuel and ammonium nitrate together, one. Number two, such a large quantity of ammonium nitrate in a small shed, which contains fuel, not only fuel, there's wax and many other things, and aluminum powder, which is under a leaky roof. Aluminum powder catches fire with water. It's a well-known fact. I think your analysis is absolutely perfect, sir. And I think such analysis or a root cause analysis we should do for every accident so that we do proper learning from the accident. Thank you very much, sir. Our next and the last paper in this session is from Mr. S.K. Roy. The subject is investigation into the accident at Amalgamated Block 2 OCP of BCCL. Mr. Roy has done his graduation in mining engineering from BIT Sindri in 1996 and joined CSIR CIMFR in 1997. He completed his MTech in Reliability and Quality Engineering in 1999 and PhD in Mining Engineering in 2009. Dr. Roy has been awarded National Geosciences Award in 2012 and Mining Engineering Design Award in 2014 for his significant contribution in mining technology. He has filed 3 Indian patents related to development and method of use of explosives. He has published 51 scientific papers in international and national journals and conferences. Presently, Dr. Roy is Senior Principal Scientist at Explosives and Explosions Laboratory of CSIR, Central Institute of Mining and Fuel Research, Dhanbad. Over to you, Mr. Roy.
Respected dignitaries on and off the dais, and good afternoon, everyone. The topic which I am going to discuss is related to an accident which happened at Amalgamated Block 2 OCP of BCCL. And although some of our previous chairperson have already raised the question about the information which we get about the incident, so I don't know whether that was correct or not, but whatever information we got, the studies were based on those information, and the incidence is like that. In an overburden bench, 41 holes were to be charged, out of which It was 14 holes were charged on 9th November. Holes were 18-meter depth, 250 dia with a regular pattern of burden 5 meter spacing 5 to 5 and 6 meter. But they could not continue the charging and blasting on that day because RECP drill machine was under breakdown. So they stopped that operation there, and next day they charged again 14 holes. But that day also they could not take out that drill machine. So in 28 holes which were charged, about 15 ton of explosives were slipping. And the configuration in which the holes were loaded has got 2 decks and 3 different nonels of different lengths of 2 different manufacturers were used in that hole. And although they decided to blast that area with only 28 holes on 14th 11, and they were trying to march the drilling machine out of that slipping hole region. But unfortunately, no officials were guiding that marching of the machine. And as per the information revealed, it was informed that the machine slipped from its usual path and came over the charged hole. And few holes, numbers are not specified, but somebody said it is 2 to 3 holes prematurely detonated, which injured the drill operator, and that machine was severely damaged. So if we look at the charging conditions, that SME explosive which was being used, or the cast booster or non-Ls, which all were inside the hole, and that 2 holes were slipping with stemming. So the only thing which was out of the hole was the non-L tubes. No. So our whole investigation was focused to find out how that non-L tube could have got initiated. So when it was initially ruled out that SME cast booster detonators of non-Ls were not the primary reasons, although with initiation of shock tube, in turn they may have got initiated, then only that SME or the hole would have initiated. So what management requested that we should study the cast booster also, although it was out of, from the information revealed, it was not coming to the picture. It is not that similar accident had not happened. It may have happened in India also. Some literature has revealed the accidents, such accidents about in other countries, out of which few I have mentioned, in which in 2 cases, one in Virginia and New South Wales, Australia, the vehicle was being backed out of that loaded holes, and that shock tube got entangled in those machines, and because of stretching, they got initiated. And in one mine, Fraser Mine, Canada, because they had put wrong delay DTH in the hole, they were trying to pull out that delay. In that process, that got initiated, and there was injury or fatality there. Another case, the hole had misfired, and it was the tube which was there was being pulled out, that whether to ascertain whether the explosive has fired or not. And there are, literature suggests that there are many reported and unreported initiation of shock tubes in extrusion facilities in manufacturing process, and it must be happening in India also. But we have personally not come across any literature which gives any data about Indian manufacturing. So the questions which were there with us to the investigation team, that it was something new to us. We had never faced similar situation in India, and probably we are facing difficulty that what standard or methodology has to be followed in this case, particular case of incidents to analyze. Another thing was that as the explosive was kept in a magazine which cannot generate RE12, So how to shift that to CMRI? Although, so it was decided that okay, we'll do the trial at field itself. However, in later case of WCL accident, we pursued with PESO officials and a mechanism was found out and we could shift the explosive from WCL mine to CMRI with their help. But in this case, the trials were done in BCCL mine quarry itself because of this difficulty also. And then the question came, because it was something which was never done, so how to fabricate those setup if there is any standard literature suggests in short time, that too in a government setup where you know that we have to go through a lot of processes. And then how many numbers of trials has to be done with each type of study which we foresee that will reveal something. And thing is that in most of the cases, if we have seen that the number of samples which are seized by the statutory authorities are too small to do anything. Like in this case, about only 30 to 35 non-Ls were there. So if you have to do 5-6 different types of trials, that sample size is too less. But even then, we tried to complete it. And then even if we generate some data, that what criteria has to be followed to say whether yes, it is the reason or it is not the reason for accident. So coming to the focus, that our focus was only to the initiation of shock tube. So the possible reasons by which it could have got initiated was impact because of that heavy earth moving machine, sudden transfer of its weight, either by its sleeping as revealed by the management may have initiated it, or it may have marched over those shock tubes, so the tube may have come in between the crawler and the hard pieces of rocks getting crushed and generating some sort of frictional spark and getting initiated. Or any other source of a spark may also have come either due to friction or spark of machine rotating parts or motors. And fourth one is that getting entangled in the drilling machine and getting overstretched, and then the common phenomena which has been revealed in literature is slap and shoot phenomena. So we could find a literature which suggests how to test the impact sensitivity of shock tube, although not Indian, but European standard is there. And it specifies, the rough diagram is given like that. Not many details have been revealed, but the schematic diagram suggests how to fabricate it. And it shows that we have to drop a 5 kg steel cylindrical hammer from a 12-meter height through a guided pipe on non-L tubes kept between two steel plates, and observe whether that tube gets initiated or not. But going by this, it was not so easy to get fabricated in 2 days' time. Had it been a private institution, it may be possible, but at SIM for some government laboratory, it may take at least 1 month's time to get it done. So we found out a solution that this dragline machine present in the open cast in that same mine, its deck height was about 12 meters. So we used that deck and suspended a guide pipe, which was the water draining pipe, and we fabricated a locally 5 kg hammer and placed the shock tubes over 2 steel plates, because specifications were not specified that what should be the specification of plates. So we took any steel plate just to give a hard surface, and we checked 25 pieces of all 3 types of non-Ls, but there were no non-L piece which got initiated. Then we tried to crush the shock tubes, although before doing this we had cut the non-L detonator end, because otherwise we may endanger the operator. So we crushed the shock tube pieces by a crawler mounted dozer, and we tried our best to see whether that gets initiated. how we were thinking that we will observe, because the change in color, because once the shock tube gets initiated, it changes the color. So nothing, some sort of indication was observed. And even some pieces, cut pieces, we initiated with later with detonator, and we found that it was getting initiated. So that possible, there also we failed to generate anything positive result. Then coming to the spark sensitivity, it is known that shock tube are supposed to be sensitive to spark. But is there any minimum spark level which is required? Like for permitted detonators, we have a certain criteria that yes, detonator is supposed to get initiated with a electric current, but we have a no fire current level that up to 180 milliampere current, it should not get initiated, even if supplied for 5 minutes. But for shock tube, I don't feel there is any such criteria, but it should be. It is supposed to get initiated with a spark or something like that because of inherent nature of the explosive product which we use for coating. But we have to find out the minimum level so that only if that exceeds it, then only it should get initiated. So with locally arranged setup, because there is no standard, so no setup was available, and we did some trial, we found some were getting initiated, some not. That shows that invariably there is some sort of minimum energy required, and as that quantity of we were unable to quantify, so some standard has to come out in this regard. Then coming to snap, slap and shoot, this phenomena has been observed by most of the manufacturers. Some of them may be having some sort of setup at their factory end to investigate, if not in India, but probably in other countries like Dyno Nobel. They did a number of experiments to find out that whether this phenomena of snap, slap can initiate shock tube, and to their surprise, they tried about 1,000 shock tubes with different stretching rate, different length of stretching, but they could not generate any positive result, that none of the shock tube got initiated. But finally, Dyno Nobel, they did not leave their effort, continued, and with at Dyno Nobel Center, they came out with a suitable setup where suddenly the same nozzle were giving 20 to 75% ignition, which earlier was not giving any ignition. So a suitable instrument has to be there to find out whether that will give a positive result or not. Probably in this case we are helpless, and going by the practical situation which would have prevailed there, we tried to simulate by stretching it using the local machines like as shown in the figure. I will confess that it was not a standard method, but still that was the only option left with us in that time. And as this figure revealed, that because the nozzle tubes were two different manufacturers, and what we found that they were breaking with a different characteristic. Like one manufacturer nozzle was getting elongated to very high length, and then because of conic formation, it was breaking at the middle. Whereas other manufacturer shock tube was getting broken even without any elongation. And in those cases, the breakage was near the sharp edge where it was tight. Whereas in other cases, it was near the middle. So it is because we don't have any standard to specify that what should be the minimum elongation or what should be the maximum elongation before which the shock tube being manufactured in India should have that characteristic. So as some of the point I already explained that we had some limitations, and probably the because of the non-availability of standard equipment, method, procedure, we are still ready to face the accident. But remedial measures will come out only if we standardize everything. Then only probably we will avoid reoccurrence of this sort of accident. Then we have to go by the the information shared by the management, and if that vehicle slipped, which you can imagine that being in a mine, crawler mounted machines does not generally slip. and how if holes were not interconnected, then that machine may have come over one hole. How 2-3 holes got initiated. And coming to the management responsibility, if holes charged on 10th, 9th, if machine was not moved out, then why holes were charged on 10th, even before taking out that machine? And if such situation was there, it should have been properly supervised. Then coming to the standard, would personally share my experience at SIMFER, that although responsibility to formulate the standard goes to BIS, we are in assisting role, but I have seen that they are too slow, and unless some proactive approach taken by PESO or DGMS is taken, it lingers for a long period. And I can cite an example that even for permitted explosive standard, although it was in good condition, but some modifications were lingering for like 5-6 years, but suddenly it came to DGMS mind, and they took it seriously, and within 3 months everything was revised. They issued a circular and everybody is following it. So something like that has to be taken by the statutory authorities. Relying on BIS probably won't help in long run. And even if that standard comes, who will take the responsibility to install the facility, all facilities, unless there is return on investment? As you know that all government laboratories are nowadays facing the financial restrictions, and unless you justify that it is really required, you won't get the fund. So I don't know whether SIMPER, PESO or DGMS will take that onus to establish those facilities. Coming to it is not that the international standards are not there, it is there. We have to just sort it out and frame it to Indian condition, or we have to take some our experience and come out with a different standard. And I still feel that we have started using non-L long back, probably we are using electronic detonators, but are we still having any standard on that? Different manufacturers may be following different specifications, they may be having some setup to their end, but it is not shared to others, and that unless it is standardized, it is published, and it is followed by everyone, we won't have a similar quality products in the market. So with this slide I would conclude and accept that although some inferences were drawn, but I would say that we could not conclude the study. Reasons may be that whether we were avoided right information, or we were not having standards, facilities, or sample size were too less, like the study which we did for crushing. Had we continued it with 100 or 150 samples, some results may have come, some samples may have failed. Or what we have observed that in field, when we go, we feel or we get an impression from the workers that they feel non-L is too safe. It is not like decal. And anything can be done. Most of the time, drills, holes are charged and then only vehicles are taken out. And that somewhere it is the manufacturer who are supplying that they are responsible to propagate this wrong notion of non-L being too safe. So we have to take a proactive role in formulating the standard, setting up the facilities for their initial, periodic, as well as random. As I can say with confidence that permitted explosive, we have enough standard and facilities, and that is why I can assure you that although we could not conclude the study at BCCL, but some accident has happened at WCL, and that study will be concluded because everything is standardized. And we have all the facilities, so we will be able to say with yes or no whether this product was involved or not. So if none is taking the responsibility, neither government nor private, then probably we have to go for public-private partnership. Like we can cite an example at SIMFER, we have a calibration facility which has been installed by a private partner, and the earning from that comes or being shared by both Simfer as well as that company. So Simfer is providing the space, the manpower, expertise, but probably the investment has been done by private. So similar models may be thought of, and because of DGMS intervention in case of permitted explosive, we feel that permitted has come to a certain safety level, but non-permitted products are still being not monitored or regulated to that extent, and a thinking has to be given. So with these words, I conclude. Thank you.
Thank you, Mr. Roy. From the experience of a manufacturer, I can tell you that both your conclusions were more or less okay. A shock tube can be certainly initiated by a spark, and this is how we actually test in our velocity of detonation test. Another one which you said, snap, we call it whipping. You know, if you whip a shock tube on a hard surface, it can sometimes explode. It's not that every time you do it, it will do, but it can. But obviously, the responsibility on this would also be shared by you, because before moving the equipment, you should not start loading the holes.
Yeah.
And once loaded, I think the hole should be immediately exploded, unless you have planned for sleeping and they are sleeping for a long time. And as they say, explosives investigations never can give you a one single reason for the accident. What happens is, the person who can tell you the story that the worker is not there, the explosive which can be analyzed and from which you can take the sample and analyze is not there. And the records, many a times when the accidents take place in the factories and all that, that also go away with the explosion. So many a times we can't come to a single cause, but certainly what you have done is a very methodical analysis, and I must congratulate you for that. With this, I think the session comes to an end, sir, and I must thank all the three speakers who did a fantastic job, Mr. Guha, Mr. Sahu, and Mr. Roy. Thank you very much.
Do we have any questions for the speakers, or shall we move ahead? No questions? All right, so we will move ahead. Thank you, Dr. A.N. Gupta and all the speakers for their case studies. I would request our chairperson, Dr. A.N. Gupta, to present the mementos to all our three speakers here today. Our first speaker, Sri Rahul Guha, Solar Industries India Limited, Nagpur. Shri N.T. Shahu, PISO, Nagpur. Dr. Sanjay Kumar Roy, CSIR CIM FR, Dhanbad. I would now request Mr. Shyam Sundar Reddy from Orissa Explosives to come up to the dais and present a memento to our chairperson for this session, Dr. A.N. Gupta. I would like to thank all our chairpersons for all 3 sessions and all the speakers. Also, I would like to thank all our dignitaries and all of you present here. With this, we conclude today's day of technical sessions at Explosafe 2016. I cordially invite all of you for our evening's entertainment program, which will commence tonight at 7:30 p.m., followed by dinner. The evening entertainers are from the band Jallosh, who would be waiting for you at the same venue at 7:30 p.m., followed by dinner. Thank you, everyone. I hope you enjoy the rest of your evening and your dinner, where you would get to meet each other, and probably the questions that you could not ask here, you would interact with each other there. Just as the last request, people who are the members of EMWA need to stay back for a meeting. The rest of you can freshen up and come back at 7:30 for the entertainment and dinner. Thank you very much, and we will see you tomorrow morning at 9.